In this video, we're going to tell the domain and range of a circle, x squared parabola, and a y squared parabola. First off, you're going to be given the equation. First instance, this is an equation for a circle. From the equation, you can derive the center and the radius, which helps you be able to graph the equation. In this case, because the center is at 3, -1, and has a radius of 3, the circle more or less is going to look like this. Now, since domain relates to x and range relates to y, when you're looking at domain, you're going to be looking along this way. Whereas if you're looking for y, you're going to look across this way. Because this is a circle, you know that the domain and range must be touching endpoints. They don't go infinitely off. So both of these are going to be using brackets. When doing domain and range, you want to go from your lowest number to your highest number. So for domain, you're going to want to go from your negative side to your positive side. The furthest most point negative is an x value of 0. Now, the highest point is an x value of 6. Now, for range, it's the same thing. You want to go from your negative scale to your positive scale. So your lowest most point is -4. And your highest most point is 2. Now there's another way to do this where you don't have to graph. And it involves taking the idea of x and y and applying it using your center. Since we know that the radius is 3 units, we can take 3 and subtract 3 to get 0. And we can also take 3 and add 3 to get 6, which gives you the same domain. Same thing applies to your y value. You can take -1 minus 3 and get -4, and then you can take -1 plus 3, get 2, which once again gives you a range of -4, 2. Now for an x squared parabola, in this case you get the equation x minus 1 squared equals -8 y plus 3, where from this equation you can find your vertex, c-value, focus, directrix, axis of symmetry, latus rectum, and your endpoints, which will overall be used to help you graph. So if you take your vertex 1, -3, c-value of 2, and since it's an x squared, it's up and down, so 2. Your directrix, your axis of symmetry, your latus rectum, and you end up getting a very decent sketch of what your x squared parabola look like. Now, because it's an x squared parabola, we know that x will always be infinitely many. So in this case, the domain is -8 infinity to positive infinity, with parentheses because you can never touch negative or positive infinity. Now, as we said before, range involves y, so in this case you're wanting to go and look this way. But since you're wanting to find your lowest point to your highest point, begins with -infinity to your highest point, which in this case is -3, which in this case also has a bracket much like these because it touches the point. A y-squared parabola is very similar. In this case, the equation is y plus 5 squared equals negative 4x minus 1. Same situation, you get your vertex, c-value, focus, directrix, axis of symmetry, lattice rectum, and endpoints, which help you graph 1, negative 5, c-value 1. Since it's y squared, it goes side to side. Your focus is this way, directrix, axis of symmetry, lattice rectum, and once again you get a basic sketch of your graph. Now, since this is a y squared parabola, we automatically know that the range will always be infinitely many. So we know in this case that the range is negative infinity to positive infinity, again with parentheses. Now, since we're looking for the domain, that would be this way. Once again, you want to go from your lowest most number to your highest most number. So your domain is negative infinity to, and your highest most number is 1 with a bracket because it's physically touching.